Okay, everybody, this is the Workgroup Device Management meeting for June 25th, 2024. And I will share the agenda. Pretty small agenda today, although we have, if there's space, I know there were other questions and things people might want to discuss. So happy to discuss that more if there's time. Sorry, here, just got to get my windows fixed up. All right. So first item here is the status update on where we are with 131, and then we'll go over what we managed to believe we're going to get into 131 versus having had to push. So Patrick, you want to take over here?
Yeah, okay. So the first PR is the one that I intend to merge for Kubernetes 131. If I get that in, we will have the new API for DRA in 131, but it's still work in progress. It also contains quite a few commits from other PRs that I want to get merged first, because then the final PR will be smaller. I'm currently at the point where I have publicly pushed the new API implementation with the hope of getting Tim to review it. But we already know that some of the choices that we made for the API and the cap are not really final. So even the API implementation in that branch, in that pull request, still needs to change a little bit. We discussed cell syntax a bit more. There's one change coming. The way how a request specifies how many devices to allocate, that probably will change. What I have locally, what I haven't pushed is the actual implementation of a new API, but I'm now slowly getting to the point where the scheduler tests are passing again. Some E2E tests are passing, and the structured parameter allocation concepts are implemented, but completely lacking unit tests or anything. So I'm really just right now still trying to iron out some of the few things that I have before pushing another update, probably today, because I also created that second issue that is in the agenda where I explain how other contributors could help with this effort. So first of all, reviewing this PR, one that John just had open, you see a lot of commits at the beginning, PRs from other PRs. You can basically ignore those or go to those PRs and help review them, but it's mostly, I think, on SIG scheduling, some a little bit on API reviewers for the V1 pod change. So I'm not sure how much other people can really help with those at the moment.
So Patrick, can I
Yep.
ask? So there are commits in the large PR in this PR that
Yes.
are in these other PRs. So if we can get these
Yes.
merged, it'll simplify
Yes.
this PR. So trying to work to get those merged early. They're all independently mergeable. We don't need those. The ones that are broken out, that's why you broke them out, right?
I broke them out because I partly I did them already a while ago and they just haven't been merged. But now that I was completely changing the API, I basically needed those changes in my branch. Otherwise, it would get horrible commit or merge conflicts. So I basically pulled everything that I had pending into my branch, then started doing the changes for 131.
But like
So
for example, if we get API reviewers to look at, say, this one here, um, this could be independently merged.
yes,
Everything will still work, but it will
yes,
simplify
yeah.
the larger PR.
That's the intent.
Okay.
The other thing is the kubelet API version bump or make kubelet independent of a resource KSIO API version. That introduces an API break, the one that we want to make in 131, but it's completely self-contained. If we stop at that point, we just have a new kubelet API that is version independent, and it's a step forward. It's not the end goal for 131, but it wouldn't be wrong to merge it. So all of those can be merged separately and ideally should be merged.
Okay, so I'll try to help. One way I can help is probably to try and talk to different approvers and see if I can get some eyeballs on them earlier to simplify the bigger PR.
Yeah. So for the kubelet PR, Jordan wanted to look at it. I think he has it on his queue somewhere.
Okay.
The others are SIG scheduling, and I've been talking with folks, so this may all proceed. So anyway, the issue basically just summarizes the current status and explains that if you look at the PR, you should probably ignore the initial commits. And then if you do a file diff, you can start looking for to-dos that I have left in the code around things that need to be added. And then we can discuss on Slack whether someone is willing to help with those to-dos.
Okay, and so there's a few really, this whole code cycle is extremely compressed. And not only that, but in the US next week, there's 2 days of holidays for most people. What's your prognosis here? Do you see this?
If I can, well, I'm still hopeful that it can be done.
Okay.
The more help I can get, the more complete the PR will be. Okay. I'm kind of counting on this extra weeks that we get for adding tests, which is a bit odd, but we do have code freeze and then we have test freeze. And it's not entirely clear to me whether that means that you're only supposed to fix tests or still can add tests, but I guess we have some wiggle room.
Yeah, I'm not all that thrilled with the way it's ridiculous for a 4-month release cycle to have 3.5 weeks of coding implementation time. But yeah. Okay. All right. Thank you. Anything else you wanted to discuss here?
No, that's
okay.
All. I'll post updates on Slack when I do my next push, so people can see it. Okay.
Awesome. Thank you. So folks on the call, yeah, if you have a few spare cycles, go to this issue here, and that will help see if there's any way you can pitch in. You can push PRs against Patrick's against Patrick's branch, and then he can merge those PRs there, and they'll flow all the way into KK. This document, the agenda document, is linked on the top of the Slack channel, but I can also put it here. Okay, so all right. So the other thing is we wanted to talk with folks. Any questions on that before we move on to the next item? Okay, so we wanted to go through. We went back a few meetings ago through the scope we had hoped to get in. That is a little bit revised. There's a few things we had really hoped to get in that there's just not enough time for. So I did update this document just before the meeting, and a few key things that have slipped out. The partitionable device model that is for managing dynamic MIG, and so we're not able to. There's no way we'll be able to get that in. We still haven't quite figured out how we want to do it. This was another one I think that was in the nice to have. We are currently going to continue with what we do in 130 and previous releases, which is if a device is not healthy, the driver just omits it from the slice rather than reports a status. One thing that moved up from nice to have was the network attached devices. Now, we haven't spent time carefully considering these use cases, but we did make the API and the subsequent implementation compatible with how we believe this will be done. So we should be able to, and Patrick, correct me if this is not accurate, but we should be able to at least handle the cases we handled previously with network attached devices. All these other things were already out of scope. This document, by the way, is divided into the capacity model. So that's what the driver publishes to say what's available on the nodes, and into the claim model. Now, in the claim model, the pieces that moved from our previous discussion out of the in scope or nice to have into the out of scope were, well, quota. Patrick, have we really landed on? I think at this point in quota, we just have sort of ideas of understanding of how we can go about doing part of it. We haven't even agreed, like, ultimately we may need all of the above, like the things we've talked about. I don't know yet, but we haven't really agreed on exactly how we're going to do it, but we've tried to put ourselves in a position where we aren't closing off any paths. I think this is probably the best way to state it.
Yeah. So you and Tim were big fans of making it class-based. So we agreed to make the device class required in a request. And we could do some limited quota mechanism by counting how many times a certain device class is being used. I do have an older PR that does that counting. That would be one way of doing quota, perhaps even in 131. The underlying problem is that if one device class gives you access to devices of different sizes and you want to limit the overall size of what is being provided to the user, it really can't be done with a class-based approach. So I think long-term we may need additional checks at allocation time to figure out what is actually being provided to the user, sum up, say, the amount of GPU memory, which is, I think, one of the main use cases that we have that goes beyond just device access control. But we don't have that planned out yet.
Right.
And it's in the current PR, I don't even have an API for setting quotas. We have something in the CAP that I haven't implemented yet because I'm still exploring or thinking about whether we actually want that new resource quota type when it's still not doing that much. So we
might not need it. We might be able to implement it in V1, the class-based in V1. Yeah.
The class-based one could be done with a V1 resource quota, but then we do need to put the admin permission somehow into that object, and that's not quite entirely clear how that would work.
Okay, so that's why I left this in the nice to have, because we might be able to deliver, but given our previous discussion of how compressed the cycle is, it seems unlikely to me. Yeah. But everything else we had previously said was in scope has stayed in scope in the last couple of weeks of discussions. The other piece here that's in the nice to have is Kevin, are you here? Do we what we landed on the API, did it have we didn't preclude this. We didn't implement anything specific for this, but we didn't preclude it, as I recall. Is that accurate? I don't know if you're here.
I'm here. Yeah, I'm trying to remember what this is.
This is the right. We wanted a way for vendors to create controllers on the control plane side that would process their own CRDs and generate objects that could be referenced in order to either through some sort of duck typing or through some sort of named object that could be used to generate claims.
Yeah, and we didn't include this.
Yeah. Okay. We didn't preclude it, right?
No. We could still add it later.
Okay.
It would just be a matter of basically saying, don't put any of these other fields in the claim spec. Instead, point to this other object and know that it's going to do that for you.
And we created a one of in the place where we needed to, such that we can add those lookups towards the other object.
Yeah, the one of would be, I don't remember what name we settled on. Did we settle
I
on
know.
devices? Is devices the name for that, Patrick?
I think that's where we
Uh,
settled. Yeah.
Yeah.
Yeah. The
say again.
devices. We're just, I'm just trying to verify. It's not so important what the name is right now. I'm just trying to verify that we put a one of in the right place such that
Yeah.
we're not precluding a future extension
But
such that we can support this behavior.
we did put in, or we agreed to put that into the request structure.
Yes.
During implementation, I found that doing the same in the resource allocation result didn't make as much sense because we wanted to have a unique identifier for everything that is allocated that is uniform. So I needed basically the driver name, pool name, and device name as a guaranteed part that is present no matter what the underlying thingy is that we've allocated. So I removed the one-off at that point, but it's still in the request because I can easily imagine different ways of representing devices and different ways to request them. And perhaps the allocation result will get extended, but what it always will have is this, what I just said, request name, because that's part of our main API, driver name for the kubelet part to handle this thing, pool name, because we say that we do have this three-part unique identifier that is composed of these three parts. So these are all common.
Okay. So I moved this to the out of scope because, well, we left the ability to extend to it. We're not going to implement it in this release. So the final general area is the allocation model and the scheduling algorithms. Or actually, there's the driver too. So the third thing is the allocation model and scheduling algorithms. This got pushed. This was originally in the new scope. So this is recording the per device status of the allocation. So let's say you make an allocation, you assign this device to this pod and this container, the driver gets that allocation and it's supposed to attach some configuration, and the configuration of that card fails. It would report that status back through the claim status. That's what this line item is. We're not going to do that. But what we are going to do is there's a separate KEP that Sergey put out that allows the reporting of the device status, effectively the same thing, through the pod status, which is where people would want to look for it anyway. So eventually we might want to have, this probably should have moved it out of scope, both of these. Eventually we might want to have something in the claim status, but it's not clear we actually need that at all. I guess for independent, for claims that are created and then reused among multiple pods, that status gets sort of duped across all those pods. Other than that, so this is that other KEP. So I put that into the new functionality in scope. There are things we need to do in our driver API to deliver that. All right. Finally, the driver side. Yeah, Abhishek.
Yeah, so the way that you were describing, it seems that the pod should exist in the system for a device to be assigned.
So I see what you're saying. You could create a claim independently of a pod, but I don't think we get rid of immediate allocation, right, Patrick? So it doesn't get allocated until a pod gets scheduled, because we don't just pick a random node to put it on. We schedule it, and then that claim gets satisfied. Once the claim's been satisfied once, then the device will be associated with that claim, and you can point additional pods at it if you want. But you can't allocate a device independent of a claim of a pod attaching to it. Is that accurate, Patrick?
This is how structured parameters work, because the scheduler handles the allocation. Nothing gets allocated unless there is a pod that is being scheduled. With classic DRA, which we still have, you could do immediate allocation even if the user is not asking for it. But that's then a choice that the driver is making, that if it sees a claim which is not allocated, it could allocate it without waiting for a pod. It's not something that's really encouraged, and I don't think it makes a difference because ultimately there really wasn't a good reason to have immediate allocation when it's just sitting there in the cluster not being used.
Okay. I mean, I just don't want to extend, but a short comment would be, I mean, you would need immediate if you have, gangs, right? And want to support all or nothing, then you have to know that, okay, this exists before my gang is being out there.
Yeah, so gang is unfortunately out of scope in this release. I think it's something this group should look at, but it is also probably beyond the scope of this group even. But like there's just too many things to do, right? So as much like I really want to address that, I feel, and I think Patrick and Kevin agree with me that at least for now, we need to walk. We need to crawl here before we're starting that.
I agree. Yeah. I agree. Yeah.
Okay. Driver side things. Nothing changed except that I moved this out of scope and I added this. What is this? So this is something I haven't talked to even Kevin or Patrick about, but one of the things as a cloud provider, we construct, we have people who construct what our VMs look like. And we already know what cards are in them, right? We already know the node shape. And we know, for example, that we have a particular NIC that we want to go along with a particular GPU, say. Now, in when we thought we were getting partitionable model, I believed we could build this composite device model on top of partitional model. So I basically a sort of meta driver that fronts multiple other drivers. But we're not getting that in this release. So a simple alternative, what we are getting is topological alignment. So I can say, I want these two devices to have a matching attribute. So if as a cloud provider, and this is really just a driver side thing in our example driver, and if and if Kevin will work with me on getting into the NVIDIA driver, that would be great. But what I'm thinking is a simple way to achieve this, at least crudely, is to have the cloud provider who knows the shape, or the VM architect, whoever it may be, who knows what various devices are in the node, can add a static file that enhances the attributes published by the driver. So it'll basically just be a YAML file with device name and additional attributes, which would be scoped, because our attributes are all scoped by domain, would be scoped with like a, in our case, a GKE.io or something / device group, or I don't know what we call it. But and then on the so we'd append that to both our NIC driver and our device driver to create the pairings of NICs and GPUs. So that way, because one of the issues we have is we have this topological alignment. So maybe PCIe route works for a NIC and a GPU, but there's, at least in our case, we have certain, there's other things that are more, there's other more sophisticated topologies around. We might have some for TPU, or there might be some associated with NVLink that we may not be able to get out of the sort of PCIe route type of thing, which we've been using for our canonical example on topological alignment. So this allows the VM architect to have some control over all the devices and create connections between them within the attributes that can be used through match attributes. So that's something I'd like us to have in our example driver, is a way to do that. But like I said, this is the first time I've raised it anywhere, so I'm curious to hear people's thoughts on that. Yeah, Abhishek.
Yeah, I mean, I had a question. So this is topology within the node, but not
Correct.
across a node, right?
So yes, because we're still scheduling pod to node. However, you could have things like as a cloud provider, I know that I have 4 NICs on this VM and they're attached to these 4 VPCs. And I can build into my cloud provider driver a attribute that identifies the VPC name that the interface is attached to, and then I can add that as an attribute. So that allows me to propagate upward information to a higher level controller, such that it can make associations. It's not perfect because it's somewhat limited in the sense that we don't have a way in the scheduler, because we don't have the gang scheduling. We don't have a way in the scheduler to say all these pods have to have the same network. We would have a way to say all these pods have to be attached to this specific network, right? Which is a different concept, but it's still useful. It's just a little more confining. So that's how I'm seeing that going up a level from single pod to multi-pod. If we need to get to the equivalent of match attributes that we're doing intranode at an internode level, an interpod level, then we need the scheduler to understand more than one pod at a time, which we aren't there yet. But there are some efforts around that in things like Q. And so how all these things are going to come together, it still isn't quite clear to me, but I've been talking to folks in those other community efforts to try and make sure at least we're aligned to make it possible.
Yeah, I mean, it's interesting. Like there is, I mean, as you described, there is a path, right? Like we attach a pod to a network rather than saying be on a specific network. So that's interesting. Yeah.
Kevin or Patrick, do you have any thoughts on this thing in the driver I'd like to do?
Sorry, I've been distracted with
That's okay.
things going on in the background
No.
at my house.
That's okay. I think it's a fairly simple idea that one of the things we've talked about, Kevin, right, is that for match attributes, we have things like PCIe root, which we know about, but as a VM architect, I may know other things about my network. So in the case of that I'm thinking of, maybe there's different NVLink domains, or there's different something about my network topology that I know about and how my NICs are attached to the network topology, and I want to avoid an extra hop right through distribution switch. And so as a cloud provider or network VM architect, I'd like to be able to provide the driver of all the drivers running on that node with static files that allow them to that they read and they use to enhance the attributes they're publishing about a device. So those could be scoped with my domain name, but they would be like, oh, this NIC is attached to this VPC, this NIC is attached to this other VPC, this NIC is attached to this other VPC. Or it could be, oh, this GPU is attached to this NVLink domain, and so are these other 4 GPUs, right? So now in that, you do start to be able to see things. If those NVLink domains are cross node, now I've got some attributes that, while we can't do cross node things within the scheduler, publishing that information in those attributes allows a higher level scheduler to say, I want everybody connected to this NVLink domain, all these pods across all these nodes. So I think that the idea of a third party, the VM architect in this case, being able to, a convention in our driver example and in the NVIDIA driver and other drivers that we produce, such that we can provide a file written by the node or VM architect, I think would be super helpful.
So you would want this to be something that some component native to Kubernetes interpreted, rather than just being some extension that we recommend drivers themselves
No, it's just a convention.
provided? It's just a convention. Okay.
Yeah. So like our example driver would say, hey, we've defined a convention. I mean, this is sort of like we have certain conventions, like, in CNI you can define IPAM, right? Like those are specifications. This would be effectively a simple specification that drivers could choose to support, that basically says, we'll read this file, and when we publish our slice, we'll, it's basically a map of device name to attributes, and we'll append those attributes to our attributes. It's pretty simple.
Yeah, I mean, it doesn't seem unreasonable. I mean, at the end of the day, we're still just going to be advertising the devices with a list of attributes. And as long as it's, these files are put in a privileged location on the host that the drivers know where to look, then I see no reason not to necessarily. Otherwise, because the alternative is you would have to like modify the slice or something.
Exactly. Yeah.
Yeah.
Yeah, Abhishek.
So even in the single node scenario, so I have a question on how will applications consume this. Like one concrete example is, and probably Kevin knows this, like Nickel has a topology XML, right? That it tries to read to get this ring all reduce or whatnot. So then that thing that gets allocated is then how is it passed to the protocols or to the application, the topology information?
But I think what Patrick's proposing isn't for the end user to consume. It's for it is at the end of the day, but it's for the driver to consume, to then include additional attributes hanging off of all of the devices that it advertises. And then you as the end user in your claim spec, I don't know how closely you've been following the newest additions for what we're going to do for 130, but the way we do selection in 130 is through a cell expression, which is a domain specific language for being able to say something like, this driver, this attribute, I want to have a device that matches that. And if you have a bunch of devices that have an attribute that you need in common, you can match on that attribute to get different devices that all have the same attribute. Now, how we would translate this directly to Nickel, I'm not sure. I need to think about that more, but this is kind of the general framework that I think John's proposing here. There's just a way to get additional attributes into the system so that users can either use them for selection or use them for matching across devices to make sure that you align on some property.
Exactly.
Okay.
Yeah. So this gets published. There's no visible difference to the end user other than there's additional attributes that aren't provided by the vendor, or the author of the original driver, but they're provided by the the person that composes a bunch of devices into a VM and runs those drivers. So it's kind of like another provider can inject some logic or enhance it with some data.
Like, for example, GKE knows what their nodes look like. They could enhance
Exactly.
our driver with additional information that our driver that we write to be portable across all these different platforms just doesn't include.
Exactly. That's exactly what I'm talking about. Okay, so that's the general scope of what's going to be in 131. And that's actually our end of our formal agenda. We had a few other items. I think, actually, Abhishek, you had an item. Did you want to discuss any of that now? We have the time. We still have 24 minutes.
I mean, I was interested in how the scoring functionality works. When you have all this now more metrics exposed to the scheduler, is there an implementation that we have already worked on which I can see, or is there some document written? I mean, those kinds of questions. Like,
so we're not going to have scoring particularly in 131, but and so there was a prototype that I did, but I think it works differently than what Patrick has in actually 130 implementation. So I don't know, Patrick, if you want to discuss about any of this? You had talked about backtracking or point Abhishek at your implementation.
So the 130 implementation was really crude. It only did pick first device for each request and move on. And if it didn't find a solution in the end, it just failed. So the one that I haven't pushed yet to my branch does at least explore other alternatives. And it pretty much explores all possible combinations before giving up. So it's kind of implementing an exhaustive search. I know in the code where to put scoring. So basically it walks through some combinations, arrives at a solution that satisfies the selectors, the constraints that we have in the current API. And with 131, it would still stop at that point, at the first solution that it finds. We could make it continue and try other solutions to see whether they achieve a better score, but we just don't have a way to score. So we don't have an API to say one solution is better than another.
That's fine. Like what I was getting at is like having an API that could be that an external control could latch on, right? I mean, and feed some other
So
type of scoring is what.
that would, you only could do that with classic D-Array. That's where your custom controller gets involved with allocation, and then it can make other choices than the scheduler. We have in 131 a slight problem if you do that with a driver that also thinks that it does structured parameters and publishes the same devices for a scheduler to use, then you have to be very careful that the scheduler and your custom controller don't allocate the same device at the same time. We don't have a good automated way of preventing that. You basically would have to configure everything exactly right to not get to allocate
Yeah,
the
I think
switches at the same time. But
I think that this is probably more of a future thing. Like what we've talked about is a few options ultimately for scoring. So the typical idea would be you evaluate all the possible solutions and you score them all and you come up with some summary score across all the requests in a claim and all the claims in a pod, and that's how you pick a node. The one path to doing that without having a custom controller, that it's not in 131, but that would be something we will explore in future releases, would be well, there's one way you could do it today with zero input from the user, which is we could arbitrarily decide that certain things are better. So it's better, if we were doing per device allocatable results, allocatable resources, which we're not, it would be better to get an exact match on the capacity and the request. Or what we are doing is we could say it's better to fill up and use up all the devices in one node versus leave some empty devices and consume a currently unconsumed node. That may be better or worse. That's kind of an administrator decision how you bin pack. So one thing we could do if we wanted to implement some scoring rather than just taking first pick, although given that we have such limited time, I think we're going to stick with what we have. But one first step would be pick some arbitrary things that we think work for most people as far as how the scoring works. And then the next step is, okay, what are the APIs we could expose, native Kubernetes APIs we could expose to allow users to set different policies? I want to spread allocations, or I want to bin pack as tightly as possible is one example. We don't even do that today in the current Kubernetes scheduler, by the way. So getting there in DRA seems a little bit far off. The third thing we could do that's kind of in between, it's kind of getting more towards what I think you're asking for, is allow the user to specify a cell function which somehow calculates a score, and a cell expression that sees, here's a device that is being tested against this particular request. or set of devices, as it were, against this particular request, and use that to calculate a score. That would be pretty hard. Not hard from an implementation standpoint, but hard for users to write those expressions, but it would be super powerful and also dangerous. So those are things we can consider in future releases, but it's not something in 131. The key, though, is, in my mind, to follow the principles we've been following, which is that anything we do needs to be evaluatable by the scheduler without, and the cluster autoscaler and the carpenters of the world, without having to instantiate anything for real. So the cell expression works for that. The set of configurable algorithms with some sort of policy API works for that, but a custom controller probably doesn't work well for that.
Okay. So a question that I had is, and pardon my ignorance. So when you say the scheduler will implement it, the scheduler is a plugin, right? It has a plugin framework with various phases that moves from left to right. So you're saying that this scoring function cannot be present in either of these phases as we move from left to right for DRA?
I mean, you could create your own plugin that does scoring. We're not doing anything with it in 131, but I don't think there's anything that would preclude you from creating your own scheduler plugin for scoring that does that evaluation. What do you think, Patrick? You're closer to the code.
It's not scoring of nodes. That's where you can do plugins. You basically would have to write your own dynamic resource plugin, or take the one that we ship in tree and modify it, and run a modified version of that plugin in your custom scheduler. But the plugin itself doesn't have a plugin mechanism where you can influence how it allocates claims.
Okay, so before even we get into those algorithms, I mean, is there an intent to enable that machinery, like at least to override or have more functionality in the plugin?
Not at the moment. I did have that
in future.
131. No,
I
no,
understand.
I had something like that in 131, where I was kind of organizing the whole dynamic resource plugin so that it had compile time plugins that could have been replaced and extended fairly easily. I removed that because it was complicated and it made the whole structure more harder to understand. So no, at this point, I don't think we'll bring it back.
So what I would ask, Abhishek, is that if you have specific use cases around customizing the scoring, you go into the use cases document and you document them in there so we don't lose track of them. And anything's up, right? This is the group that decides what goes in the future. It's not me, it's not Patrick, it's not Kevin. We're facilitators in this. It's this group here and all of us that make those decisions, and obviously it's open source. So we're open for PRs as well. So those are, that's where it has to go. Otherwise, we're kind of organizing it and leading it and facilitating it. And, in Patrick's case, writing 99% of it, but it's this whole group that makes these decisions.
Okay. Yeah. I'll add that use case. Yeah. Thank you.
Awesome. We have about 15 minutes left. I have this item. I have a couple items. This is not urgent. This is gonna. I haven't updated this. What I did is, we'll quickly go through this. So what I did is, I went through, but I didn't update it for the latest decisions on scope. But I went through these concrete use cases, and I added here when I believe we will be delivering that use case, or that's what our target is anyway. I haven't gone through and updated it for the latest decision to push partitionable devices out. So it's probably a little bit off, but I'll try to do that soon. So if anybody wants to look through this and give any feedback, I'm trying to make sure that we're communicating clearly to the rest of this group what they can expect in 131 versus 130. You know, I mean, what things that I've only said basically what we're doing in alpha is 131 gets into beta in 132, and then everything else that's sort of like speculative. I just put a question mark by. But surprisingly, we're delivering a large chunk of these use cases. Kevin, I don't know that all of your use cases are reflected in this set of concrete use cases. So
I
we would
don't
want to check
know
that.
this document necessarily. Go up to the, is this the same document that
This is the same
we've
document.
had for a while? Mhm.
Yes, but what we did is some of these use cases were kind of general. And so a few weeks ago, we added this section on concrete use cases, and we just tried to like nail down. I think yeah, I think there's some things in
I
here.
added some in here, but I don't know if
Yeah,
I didn't make sure it had parity with my document though.
right.
Could you add a link to the chat, please?
Sure.
It's also linked in the Slack channel at the top.
Thanks.
Yeah, so it should be linked from here as well. Yeah, so it's linked here in the agenda document. So I'm not going to do that live here because it's a waste of everybody's time, but I'll try to go through that in the next day or two. I kind of back-to-back meetings today, but and try to update that. There's just a few minor tweaks based on the things we pushed out of 131. So that's it. I think we've covered enough. Unless Doug is here, I don't know if we have time to cover this. I don't. Is Doug here? I don't know who Doug is. I'm sorry. All right, I'll take that as a no. All right, anything else, anybody, or shall we call it 10 minutes early? Oh, Varun?
Yeah, hi. I have a question. So is there a way in the DRA framework to ensure that when the driver allocates a device to a pod, it provides enough metadata about the device so that an application can benefit from it?
So that's
So-
a driver specific thing. So when you allocate something, if your driver has the ability to modify the OCI runtime spec however it wants in order to get the device injected. So your driver in theory could set a bunch of environment variables and do a bunch of other stuff that makes its way into the container so your container can figure it out.
Mhm.
But it's not something that Kubernetes does for you. It's something your driver would need to provide for you.
Yeah, it's
Yeah,
just that different vendors would implement their things differently and provide different sets of metadata that may not always work for an application.
So we do have this requirement here, but as Kevin said, like it's dependent on the drivers to implement it a certain way. But if you have some specific concrete like examples, that might really help us make sure we're not missing something that's important that we need in the Kubernetes layer. You know, like exposing certain things through downward API or whatever it may be. If there's something like that we think we've got it covered, but concrete examples would be super helpful to make sure we don't break something. Or if there's you're saying different vendors might expose things in different ways. If there's a suggestion you have or use cases around like, oh, here's a use case where I need different vendors to expose similar data in a certain way, it would be really helpful to get that kind of concrete examples and make sure we're not leaving some gaps in there.
So, like, a naive case would be, like, if I get a full GPU for my pod, I'd want its PCI address. And then if I get a virtual GPU, then I would want its mediated device UUID. Those are the
What,
two.
what do you mean
two-
by what do you mean by you would want it? I'm just,
Uh,
what I'm asking, I guess, is that, you know, if you get access to a GPU, it gets injected into your container, and then if you run something like NVIDIA SMI, it gives you all the information about the GPUs you have access to, which include the PCIe bus ID, for example.
Yeah, so my use case is more it's on KubeVirt, which is the stack to run virtual machine on Kubernetes. And the way that works is we allocate that device to a pod worker pod, and then that worker pod is responsible for talking to libvirt on the host and run the actual virtual machine. And then libvirt needs PCI address for a full GPU, and that need not necessarily be on the PCI driver. It can be on any other driver, VFIO, for example, and we only need the PCI address for it to work.
So you're asking for certain metadata that's, so the question for a PCI device, you know, I can imagine we could figure out a way to expose that, but if there's vendor specific information,
I think a decent API, I don't know if we haven't talked about this before, but if we had something like the downward API, you could potentially ask it to set an environment variable to a specific attribute that your driver's advertising. That seems like something that would be possible, but we haven't talked about that before. Because then it becomes not some standard that every driver would need to follow, but you as the user say, I need this information, and you know there's a way to get it.
But so who would be like providing that information?
So right now, what Kevin's suggesting is there's every device publishes, every driver publishes a bunch of data about a device, all the attributes. We use it in the scheduling and allocation. And he's suggesting maybe we could add something in the claim spec. It's not clear where we'd add it because you have multiple claims, and then each claim has multiple requests, and each request has multiple devices. So you have to keep that whole tree. Right? But somewhere in that path, we could add something equivalent to the downward API where you say, hey, expose this attribute from that device that got selected to the workload as an environment variable. And so you would configure in your claim spec somewhere that association between attribute and environment variable. I mean, another option is to have a convention where we publish all of that metadata to a file somewhere, and you can mount that right as a volume in your pod and read it, right? So I think that's kind of what this was supposed to be getting at. We believe, though, we had covered it with the CDI pieces, but it sounds like maybe there's an opportunity for doing more.
Yeah, CDI just means that the driver has the opportunity to do it. It's not user driven.
Get the user to do it, yeah. But in your case of KubeVirt, that would mean, you know, it's in the pod spec for that virtual machine are those claims, and then those claims have to have some specific configuration that allows this publishing of that data down to your container. So does that meet your, if we did that, would that meet your use case, or
yeah
okay.
That's exactly what we're looking for. So currently, right, KubeVirt works with device plugins, and the problem that we have there is that KubeVirt expects a very specific environment variable to be set for us to consume that device. And then any device plugin vendor we work with would actually need to set that environment variable. And then that's a problem for adoption, that we cannot pick up any vendor on the market to work with KubeVirt. And that's why I'm hoping DRA would have a solution around that.
So I suspect that, well, let me ask. The solution we're talking about relies on the user putting it in the spec, as opposed to a solution under the hood, like the thing I talked about earlier, where a node author, a VM architect could enhance what the driver does, is something controlled by the provider, one of the providers, right? And in your case, is this something you actually want the user to specify, or is this something KubeVirt itself under the hood should automatically do? And if that's the case, then it's a different solution we want than the downward API type solution.
So if we expect the user to provide it, then KubeVirt can work with that, right? It can understand that this is what the user asked for or provided, and then we can extract the information through that. So it doesn't necessarily have to be an under the hood solution.
What would be preferred? As I guess kind of what I'm asking. I'm just trying to understand the real requirement. Like, if I were writing KubeVirt, I would be like, I don't want my users to have to understand how to configure this. I just want them to be able to make a claim in DRA, and it gets assigned to this thing like it would in anything else, like it would to any other pod, and it works, right? So it happens behind the scenes under the hood. If the user's like, well, because I'm using KubeVirt, I have to specially add a special set of configuration to my DRA claim. Now I can't pull down some, package from the internet and just run it. I have to do something special to it. So I don't know if that's quite the case, because they're special pods. They're not like regular pods or VM pods. So maybe it's okay. I'm just trying to suss out the actual requirement. We're out of time, but if you can answer quickly. Yeah.
So let me throw one quick note real quick. This is one of the things that we took as a principle early on in Kubernetes, that it's better for the user to be able to specify the exact injection of information into their workloads. That's why we don't have a bunch of, cube something variables defined. Users define how they want to do it. That's where we got the downward API and the value from and variables and things like that. The CDI mechanism seems great if it's the NVIDIA driver passing information up to the NVIDIA runtime libraries, where the user doesn't need to care about the name of that thing. It's more of an implementation detail. If we want to provide a way for users to control the name of the variable or the name of the file, there's some abstraction that we need. We need to be able to figure out what is the true name of it and what is the name that we're giving it to the user as. And I don't think we've defined that yet. I don't think we know what we don't know yet.
Yeah, I'd agree.
Yep.
All right. Any last comments, Varun?
No, that's kind of the problem that I'm trying to solve with KubeVirt.
Okay. Would you mind finding a place somewhere in the use case requirements document that we talked about earlier to add this so that we don't lose track of it?
Okay.
I don't think it's going to happen for you in 131. Sorry about that.
Sure. Yeah.
Okay. Thank you. Thanks, everybody.
Bye-bye.
Bye-bye.